Okay, so we want to add, or not add, we want to multiply two functions together here. We're asked to find g times h. And again, I'm going to define these functions as f of x equals square root of x, g of x equals x minus 2, and h of x equals 1 over x. We want to find g times h, which is a lazy way of saying we want to find g times h of x. So again, they're kind of leaving out some of the details of the notation. And again, that's sort of acceptable, but it's nice to have the full notation there. Before we get started, I just wanted to point out the domains of these functions. F of x has a domain of 0 to infinity. G of x has a domain of negative infinity to infinity. And h of x, being the function 1 over x, has a domain of negative infinity to 0, union 0 to infinity, because what we're doing there is we're leaving out the number 0. X is not allowed to equal 0 in that function, so we're skipping over 0. Right, and we want to find the function g times h, which is g times h of x. So let's go ahead and do that. Right? And the definition of g times h of x is that equals g of x times h of x. And what we're going to do is, just like in the last example, we're going to substitute in place of g of x, the thing that g of x is equal to. And in place of h of x, we're going to plug in what h of x is equal to. And we're just going to swap them out. And again, this is easier than the earlier problems we did because we don't have to plug any numbers in and do any calculations. We're just going to multiply these two expressions together, and it usually isn't much work, because usually there's not much you can do to simplify. So in place of g of x, we're going to plug in x minus 2 because g of x is equal to x minus 2. So in place of g of x, we're going to have x minus 2. For h of x is equal to 1 over x. And so in place of h of x, we're going to plug in 1 over x. And what we want to do with these two functions is we want to multiply them together. And we are multiplying it to a fraction, right? X minus 2 is getting multiplied to a fraction, so be careful in how you think about that. Think of x minus 2 as a fraction. Think of it as being over 1. And when you multiply these together, you end up getting x minus 2 over x. All right, and that's all you can do. There's nothing else you can do to simplify this. I guess you could write it in a slightly different way, but you might as well just leave it this way. So you get g times h of x equals x minus 2 over x. So again, that's really not too hard to do. You just slap the two functions together and you're done. I kind of think the hard part is determining the domain of this function. So we need to determine what is the domain of this new function that we've just created. And the rule is the domain of the new function will be the overlap of the domain of the original functions. So I need to take, in this case, g and h. Let's find where these two domains overlap each other. That will be the domain of g times h of x. And so a good way to find where they're overlapping each other is, again, to draw them both on the same real number line. So I guess I forgot to label this one here, but the domain of g is all real numbers, so it's this green line here. It covers everything. The domain of h is everything except for 0. So we use an open circle to skip over the number 0. So we shade in everywhere else except for the number 0. Where do these overlap each other? They overlap each other almost everywhere except at the number 0. So they overlap everywhere to the left of 0. That's this interval right here, negative infinity to 0. And they overlap everywhere to the right of 0, which is this interval here, 0 to infinity. And we union those together. And so again, it coincidentally turns out to be the same domain as h of x to begin with. But again, you want to find where they're overlapping each other. That's the domain of the new function that you've just created. So the new function is x minus 2 over x, and its domain would be negative infinity to 0, union 0 to infinity. Right. I want to look at one more example at this time anyways. So let's find g divided by f. And so the two relevant functions here are going to be f of x equals the square root of x, and g of x equals x minus 2. We want to find g divided by x. Again, that's a lazy way of saying we're looking for g over f of x. So that's the rest of the function notation there. A little bit later on, this will become relevant. The domain of f is 0 to infinity again, and the domain of g is negative infinity to infinity. All right, so g over f of x, by definition, is equal to g of x over f of x. And I guess I got a little bit ahead of myself here. So what we're going to do is replace. We're going to replace g of x with x minus 2, because that's what g of x is equal to. And we're going to replace f of x with the square root of x. And so it'll look like this. And again, there's really not much we can do here to simplify. You could rationalize the denominator, but for the purposes of this exercise, it's okay to just leave the square root in the denominator, right? And so that's our final answer. That's what g over f is equal to. Now let's find the domain of this new function we've just created. To do that, we want to find the overlap of the domains of the original two functions. But this is something we've already done. We did f plus g of x earlier, and in that case, we found the overlap of the domains of f and g, and they're going to overlap in the same way here. So even though we're doing something different with the functions this time, the domains are going to overlap in exactly the same way. And what we found earlier is that they overlap from 0 to infinity. And so that's going to be the domain of this new function we've created. Almost, right? There's one little extra detail we have to be careful about. So if you recall at the beginning of this section, when I talked about finding the domains of these things, the domain of the division of functions has an extra precaution that we have to take, in that we don't want to divide by 0. So f of x by itself, it's okay for f of x to equal 0. You can plug in 0 for x here. You get the square root of 0, which is 0, and that's okay when f of x is by itself. But when f of x is the denominator of a fraction, that's not okay anymore. You can't have 0 in the denominator, so it's not okay for f of x to equal 0 at this point. But the domains don't reflect that yet. And so when would f of x equal 0? It's equal to 0 when I plug in 0 for x. And I have to take that out of the domain because that's no longer okay to do. And so here 0 is being included, right? The brackets includes the 0, but technically in this new function we've created, 0 is no longer okay, so we need to remove 0 from this domain. Right? So here it's not okay for x to equal 0 in this denominator, which means we're going to change this bracket to a parentheses. And now we've left 0 out as well, and so that's the domain of this new function we've just created. The new domain will be 0 to infinity, not including 0. All right, so that's the domain.